Hi everyone, I am Yashing from Tokyo Institute of Technology. Here I will introduce our work Speech2Talking-Face, Inferring and Driving a Face with Synchronized Audio-Visual Representation. First, let's see a demo video produced by our method.
David Wayne he's got a really specific, but very different approach, but it was fun because he just let us try.
The success is my greatest success in the U.S. as well, #1 there, top 10.
Previous methods have sought to associate facial appearances with the human speech in a data-driven manner. Some work generates static facial image from voice. Other works have succeeded in driving a face-to-speak conditioning on audios. But no method has explored the possibility of inferring and driving an image in a unified framework, which have potential usage in many scenarios. Thus we propose S2TF framework to accomplish it. To tackle this problem, we take the inspiration from the AAAI paper DAVS, Disentangled Audiovisual System, which shows that talking face sequence is a composition of both subject and speech-related information. And both audio and video can serve as speech-related inputs for generation, which motivates us to learn subject and speech-related latent space for both modalities. The core ideas of our method are as follows. We design our Speech2Talking-Face system as shown here. Audio and visual representations are synchronized in identity space and identity-irrelevant space in a style-based generative framework. In identity space, we aim to learn an audio encoder to extract identity-related information. Audio-visual contrastive learning is leveraged to pull the audio representation to visual representation as close as possible. The centroid learning further encourages distinctive encoded feature. In identity-irrelevant space, we aim to learn an audio encoder to extract speech-related information. However, identity-irrelevant space contains information such as head pose, which cannot be inferred from speech. So we synchronize delta visual features with audio feature to focus on dynamic changes between frames. Features from the two spaces are concatenated and sent to a StyleGAN2-based generator. The generator would implicitly balance the information between these two spaces. This is the whole pipeline of our work. Quantitative results demonstrate our work achieves high-quality image synthesis and accurate lip synchronization. User study also shows that our results is of higher similarity and quality. Additionally, although our method is not designed for cross-modal matching, the results are comparable to theirs.
And Olive isn't really like that. She's actually pretty confident, but she's...
I think that's great that Nike gives me that type of power that I can say, hey, I don't like this, or I like this, let's try to do this and just try to do that. And
about both personal and in terms of your campaigning. But I want to begin with a thought about your career. There are very...
Simply, I can't just believe in Jesus, but then do whatever I want, living my life however I think is right. Because
the Generation X, generation,
right.
We're moving forward.
You have to be able to play this in a movie theater, and I met Oren, and 3 years later we.
Twister. That's how it was described in the script, and so that's sort of what we went for.
Oh, there being a tape and a video, and I know that, so I want to see the state that I was in.
Like a family. From outside, it seems like a big club, but when you're inside, it's like a family.
Here we conclude key points of our work. Through explicit design of two synchronized spaces, high-quality facial appearances, with accurate lip sync only from speech, could be achieved. Synchronization with centroid learning in the identity space learns a more compact identity association between speech and human faces. Style-based generator is capable of information balancing through curriculum training. Thank you for watching.